Emerging pollutants. The National Research Council, CNR, is the largest public research institution in Italy. CNR's mission is to provide the technologies and solutions to emerging public and private needs, and to contribute to the qualification of human resources. On the 30th of March, our classroom went on a visit to CNR in Bologna, and we talked about emerging pollutants, especially how to remove them from potable water. But first of all, we need to clarify what are emerging pollutants. They are defined as synthetic or natural chemical substances that aren't commonly monitored in the environment, but they have the potential to provoke known or suspected negative effects on the environment and human health. Some of the emerging well-known pollutants are heavy metals, microplastics, and API, active pharmaceutical ingredients. The techniques used to remove EP are, for example, nanofiltration and ultrafiltration. The removal techniques. During this day, we have created an example of a membrane that is used for the ultrafiltration. In fact, it works by using a pressure gradient to force water through a semi-permeable membrane, leaving larger particles and trapped minerals on the other side to remove microplastics and PFAs. We have took with a spoon a small quantity of polysulfone, a polymer with high density that was dissolved in an organic solvent. With an instrument called the applicator knife, we spread the polymer on a plastic support to create a 30-micron layer. Then we put it into the water. The organic solvent has been dissolved by this one, and the polymer formed a white solid membrane. Another experiment that we have done is the ultrafiltration of milk, previously diluted 25 times to not block the filter with this matter. We picked up a small quantity of this solution with a syringe and we filter it through these little filter tubes shown in the video, containing polysulfone membranes. We did another filtration, but this time we have used water. We filled the column with the tap on the base, first with a cotton pad to not clog the column, and then polysulfone fragments over it, pressing and compacting all that. After that, we opened the tap and filtered the water, previously colored with a pink dye used to color clothes called rhodamine. The water passed through this sort of filter, and then we picked the purified water in a glass. What we can see is that the water lost its pink dye. That's because the polysulfone membrane withheld the coloring. In fact, by combining graphene oxide sheets with polysulfone membranes, they create filters capable of capturing organic contaminants, which aren't often eliminated by conventional treatments. One of the advantages by using graphene is that it doesn't release its particles in the water. The last experiment we did was to compare the graphene oxide and the activated carbon. The activated carbon can't remove heavy metals. Instead, the graphene oxide can, but for the expensive price it has, they need to use the activated carbon. As we can see in the picture, the left tube has the pink color of the rhodamine, so the activated carbon put in it didn't filter the water well. The right tube with the graphene oxide instead absorbed the pink color. In fact, it has an absorbing surface of 2,500 square meters, the double of the activated carbon. Finally, what we can say is that there are lots of different contaminants that are emerging and that will be discovered in the next few years. They are everywhere and also in the water that we drink every day. Fortunately, scientists are discovering new ways to remove them, for example with the use of nanomaterials like graphene oxide.